Hello everyone, this is Dr. Nirmal from Jaipur Dental College. Today I am discussing on restoration of decayed primary, young permanent and permanent teeth in children using various restorative materials. This topic includes introduction, factor affecting choosing material, requirement of an ideal restorative material, GIC composite, silver amalgams, polycarbonates and resin crowns, stainless steel crown along with zirconia crown. In this part 1, I will discuss only GIC composite and silver amalgam and polycarbonates and resin crowns, stainless steel crown along with zirconia crown will be discussed by Dr. Herajit in part 2. Now come to the introduction. Pediatric dental care is an integral component of a child's overall wellness. Most of the restorative materials used have inherent shortcomings such as mercury toxicity associated with amalgam, initial poor strength of glass ionomer cements, polymerization shrinkage, and micro leakage associated with composites, as also the anesthetic appearance of stainless steel crowns. The modern restorative material have demonstrated success by inhibiting secondary caries at restoration margins and have the ability to enhance remineralization by inhibiting adjacent proximal caries. The loss of even part of a human tooth should be considered a serious injury, and that dentistry's goal should be to preserve healthy natural tooth structure. Now come to the factors choosing in material. There are various factors such as age factor, carries risk, cooperation of child, types of material, types of tooth. Age factors. What can the child handle, such as rubber dam, local anesthetics, long of attention span, and how long will the restoration need to last? Okay, caries factors. Number of caries teeth involvement, size of lesions, likelihood of further acid attacks, and need for caries control. First, fluoride releasing materials desired, motivation and compliance of patients and caregiver, oral hygiene and diet. Cooperation of child. Nature of child's behavior. Highly technique sensitive procedures may be incorporated in children whose behavior is not favorable. Considerable of caries control procedure. Next is choice of material. Material availability. Minimal psychological trauma to the child. Requirement of an ideal restorative material. Restoration of aesthetics. Maintenance of the physical strength of the crown, preserving the anatomy of the occlusal surface and thus preserving the interrelationship with the opposing and adjacent teeth, preventing further ingestions of bacteria or their byproducts into microspaces, long-term adhesion. Now come to the GIC. Wilson and Ken developed the glass ionomer cement in 1972. GIC is a hybrid of silicate cement, that is powder part, and the polycarboxylate is the liquid part. Properties of GIC: low solubility, coefficient of thermal expansion similar to dentine, fluoride release and fluoride recharge, high compressive strength, low flexural strength. Low shear strength, dimensional change, slight expansion and shrink on setting, expand with a water substance, brittle, lacks translucency, rough surface textures, biocompatible to tissues. Now indications: non-stress bearing areas, class 3, class 4, class 3 and class 5 restoration in adults, and class 2 and class 1 and class 2 restoration in primary dentitions, temporary or caries control restoration, crown margins repairs, cement based under amalgam resin, ceramics, direct and indirect gold. Core build-ups when at least 3 walls of the tooth are remaining. Now contraindication: high stresses applications, class 4 and class 2 restoration, cast replacement, core build-ups with less than 3 sound walls remaining. Now advantage: it is a tooth color material adhere directly to both enamel and dentin through an ion exchange mechanism. Biologically active, as it is capable of releasing fluoride, calcium, phosphate ions. And disadvantage is its physical properties are not sufficient to enable it to withstand heavy occlusal load in a large restorations. Now classification according to Phillips, the following is the accepted classification. Type 1, luting, cementation of crown, bridges and orthodontic devices. Powder liquid ratio is 1.5:1, radio opaque. Now type 2 is restorative. Type 2 further divided into type 2-1 restorative aesthetic. All types of aesthetic restoration or to cure or agent modified. Powder liquid ratio is 3:1 or greater. Radio opaque, high physical properties. Type 2 is restorative. Restoration under high occlusal rate, auto cure, or resin modified. Powder liquid is ratio is 3:1 or greater. Radiopaque used as a dentin substitute or interim restoration. Now type 3, lining or base. Simple lining under a metallic restoration. Powder liquid ratio is 1.5:1. Auto cure, radiopaque, high strength base for lamination technique. Now constituent. It's constitute mainly powder and liquid. Powder is essentially a calcium fluoroaluminosilicate glass, and liquid is essentially a polyalkanoic acid. The usual acid is a 40 to 55% solutions of a 2:1 polyacrylic or etaconic acid copolymer in water, or a copolymer of maleic acid and polyacrylic acid. Setting reaction. It has been described as an acid-base reaction. The surface of the glass particle is softened by the polyacrylic acid, and both calcium and aluminum ions are released through a proton attack. Calcium ions react first and form calcium polyacrylate chains, followed a little later by similar reactions with aluminum ions. Further ion exchange reaction occurs as a part of the setting progress, where there will be a silica hydrogel formed on a surface of glass particles. Now, methods of using glass ionomer. Hand mixing. Divide the dispensed powder into 2 equal parts. Gently spread the liquid drop a little over the mixing pad. Roll the first half of the powder into the liquid and incorporate together together rapidly. This is completed in 10 seconds, and the rest of the powder is brought into the mix. The final mix should be completed within 25 to 30 seconds. Recent developments of JICs, modified powder liquid system. To be able to accomplish this task, a specialized processing procedure for powder was followed, specialized granule. This system has improved wetting of the powder by liquid, rendering the mixing process much easier and faster. Capsule. These capsules contains pre-measured glass ionomer powder and liquid, which ensures correct ratio, consistency of mix, and predictable results. Paste and paste dispensing system. This is the latest development in the glass ionomer cement technology. Modified glass ionomer cements. Metal modified glass ionomer, silver alloy admixed silver amalgam alloy particle mixed with glass particles. The additions of metal powders or fiber to glass monomer ionomer cements can improve strength. Sweet and Wilson found that metal fibers were best for increasing flexural strength. Simon suggested mixing amalgam alloys powder into the cement and development this system clinically under the name of Miracle Mix. Resin modified glass ionomer. Resin modified glass ionomer cement was designed to produce favorable physical properties similar to those of resin composites, while maintaining the basic feature of the conventional glass ionomer cement. In their simplest form, these are GICs with the addition of the small quantity of the resin, such as hydroxyethyl methacrylate HEMA or BGMA in the liquid. More complex materials have been developed by modifications of the polyacid with side chain, and can be polymerized by a light curing mechanism. The first commercial RMGICs were liner by Trebont 3M. High strength packable or high viscosity glass ionomers. These glass ionomers particularly used for atraumatic restorative treatment technique. They were designed as a alternative to amalgam for posterior preventive restoration. Example, highly viscous glass ionomer cements are Fuji 9 and Katak Molar. Now come to the composite parts. Dental composites are the complex of two color filling material composed of synthetic polymers, particulate ceramic, reinforcing fillers molecules which promotes or modify the polymerization reaction that produce the cross-link polymer matrix from the dimethacrylate resin monomers, and silent coupling agents which bond the reinforcing filler to the polymer matrix. Properties of composites. Linear coefficients of thermal expansion. It is the rate of the dimensional change of the material per unit change in temperature. Water absorption. When the restorative material absorbs water, its property changes, and therefore its effectiveness and as a restorative material is usually diminished. Wear resistance. Wear resistance of composite is generally good. Surface texture. It is the smoothness of the surface of the restorative material. Microfill composites offer the smoothest restorative surface. Hybrid composites also provide surface textures that are both aesthetics and compatible with soft tissues. Radio opacity. Aesthetics restorative material must sufficiently radio opaque so that the radiolucent image of a recent carries around or under restoration can be more easily seen in radiograph. Modulus of elasticity. It is the stiffness of the material. A material having a higher modulus is more rigid. Conversely, a material with a lower modulus is more flexible. Solubility. Composite materials do not demonstrate any clinically relevant solution. Polymerization. Full polymerization the material is determined by the degree of conversion of monomers into polymers, indicating the number of methacrylates groups that have reacted with each other during the conversion process. Now indications. In case of class 1, 2, 3, 4, 5 and 6 restoration, foundation of Corby lab sealants, preventive resin restoration, aesthetic enhancement procedures, partial or full veneers, tooth contour modification, diastema closures, cements for indirect restoration, temporary restoration, periodontal splinting. Contraindication. If the operating site cannot be isolated from contamination by oral fluids, if all of the occlusal load will be on the restorative material. Economics. Restoration that extend onto the root surface may result in less ideal marginal integrity. Advantages. Aesthetics, conservative tooth structure removal, tooth preparation is simple, have low thermal conductivity, use almost universally bonded to tooth structure, repairable. Disadvantages are may have gap formation, time consuming, costly, establishing proximal contacts, axial contours, embrasures may be more difficult, technique sensitive, exhibit greater occlusal wear in areas of high occlusal stresses, marginal leakage can occur. Now come to the classification, which is classified by Lewis and Phillips in 1983. Microfield composite. This type of is also known as conventional or traditional microfield composite. The filler in this material are amorphous filler particles of 0.04 mm average diameter. Hybrid composite. They contains a combination micro and macropillar particles and are probably most commonly used composite resins. Factors that influence the composite resin's polymerization process. Curing time. It depends on the resin set, light intensity box, the resin thickness, curing through the tooth structure, etc. Set of resin. Darker composite sets cure more slowly and less lively than lighter sets. Temperature. Composite at room temperature are cure more completely and rapidly. Thickness of resin. Optimum thickness is 1 to 2 mm. Type of filler. Micro fine composites are more difficult to cure than heavily loaded composites. Distance between light and resin. Optimum distance less than 1 mm with the light positions 90 degrees from the composite surface. Light shoots quality. Wavelength between the 400 to 500 nanometer. A power density about the 600 microwave per centimeter square is required to ensure that the 400 microwave per centimeter square reaches the first increment of the composite in the posterior box. Polymerization shrinkage depends on the amount of organic phase. Varieties of composites are as follows. Flowable composites. These are low viscosity composite resins, making them more fluid than conventional composite resins. The percentage of inorganic filler is lower, and some substance of rheological modifiers, which are mainly intended to improve the handling properties, have been removed from their composition. And their advantages are high wettability on the tooth surface, ensuring penetration into the every irregularity, ability to form layers of minimum thickness. Drawbacks are a high curing shrinkage due to the lower filler load and weaker mechanical properties. These are indicated in class 5 restoration, cervical wear process, minimal occlusal restoration. Now the condensable composites. Condensable composites are composite resin with a high percentage of filler. Advantages are condensability, greater each in achieving a good contact point and better reproduction of occlusal anatomy. Their main disadvantages are difficulties in adaptation between one composite layer and another, difficult handling and pouring aesthetic in anteriority. Indication in class 2 cavity restoration in order to achieve better contact point. Or Musar. The word originally derived from organically modified ceramic were originally developed for science and technology. The organic polymers influence the polarity, the ability to cross-link hardness and optical behaviors. The glass ceramic components are responsible for thermal expansion and chemical stability. Conformer. The word conformer comes from the composite and glass ionomer. Conformers are composed of the composite and glass ionomer components in an attempt to take advantage of the desirable qualities of both materials. Conformer restorations have been shown to have insufficient restoration without penetration, pre-treatment of the dental hard tissue with an adhesive system. Conformer are most suitable for the restoration in the deciduous dentition due to their low abrasive resistance. In cervical restoration, conformer restoration perform better than resin-modified glass ionomer, but not as well as hybrid composite. Now, siluran. The name of this material class refers to its chemical composition from siloxanes and oxidants. This product class aims to have the lower shrinkage and longer resistance to fading and less marginal discoloration. The fillers in Filtech siluran are the only siluran material on the market at the moment consists of 0.1 to 2 micrometer quartz particles and radiopaque yttrium fluoride. The adhesion of streptococci observed on the surface of the siluran restoration was low and maybe because of its hydrophobic properties. Now come to geomer. Recently introduced hybrid aesthetic restorative material based on the pre-reacted glass ionomer technology. Chemically, it is fluoroaluminosilicate glass reacted with polyalkanoic acid in water prior to inclusion into silica-filled urethane resin. These are mainly indicated for the restoration of root caries, cervical caries, class 5 cavities, and also in restoration of primary teeth. The advantages includes continuous fluoride release, clinical stability, high biocompatibility, high aesthetic, and ease of bonding. Now come to the silver amalgam. Dentists have used it for restoring the teeth for more than 150 years. The popularity of the dental amalgam likely will continue to decline as the longevity of these other materials and their suitability. Dental amalgam is produced by mixing liquid mercury with solid particle of an alloy of silver, tin, copper, and sometimes zinc, palladium, indium, and selenium. This combination of solid metal is known as the amalgam alloy. Classification based on copper content: high copper and low copper. Now, in high copper, the copper is more than 12% and low copper less than 6% copper present. Based on zinc content, zinc content in alloy with more than 0.01% zinc and alloys with less than 0.01% zinc. Based on particle shape, lead cut and spherical particle. Lead cut irregularly shaped fillings produced by cutting an ingot of alloy on a lead. Spherical produced by atomizing the alloy whilst still liquid into the stream of inert gas. Physical properties: compressive strength. The resistance to compression of forces is the most favorable strength characteristic of amalgam. The high copper and unicompositional material have the highest early compressive strength of more than 250 MPa at 1 hour. The compressive strength at 1 hour was lowest for the lead cut alloy, 45 MPa. High values of early compressive strength are an advantage for an amalgam because they reduce the possibility of fracture by prematurely high contact stresses from the patient before the final strength is reached. Tensile strength are the only fraction of their compressive strengths. Therefore, cavity design should be constructed to reduce tensile stress resulting from biting forces. Transverse strength. These values are sometimes referred to as the modulus of rupture. Because amalgams are brittle material, they can withstand little deformation during the transverse strength testing. Elastic modulus. When the elastic modulus is determined at low rates of loading such as 0.025 to 0.0125 mm per minute, values in the range of 11 to 20 GPa are obtained. High copper alloys tend to be steeper than the low copper alloys. Creep. Higher the creep magnitude, the greater the degree of the marginal deterioration. The highest values of 6.3% was found for the low copper card alloy, and the lowest values 0.05% to 0.09% were determined for the high copper unicompositional spherical alloy. Corrosion is the progressive destruction of the metal by chemical or electrochemical reaction with its environment. Excessive corrosion can lead to increased porosity, reduced marginal integrity. The presence of the relatively high percentage of tin and low copper alloy reduces the corrosion resistance. The average depth of corrosion for the most amalgam alloy is 100 to 500 pm. Now indication: moderate to large restoration that are not highly aesthetic areas of the mouth, in case that heavy occlusal contacts, in case where the cannot be well isolated, in case where the extend onto the root surface foundations, abutment teeth for the removable partial denture, temporary or carriage control restoration. Contraindication of amalgam: aesthetically prominent areas of posterior teeth, small to moderate class 1 and class 2 restoration that can be well isolated, small class 6 restorations. Advantage of amalgam: ease of use, high tensile strength, excellent wear resistance, favorable long-term clinical research results, low cost than for composite restorations. Now, disadvantage of amalgam: non-isolating, non-static, weakens the tooth structure, more technique sensitive, more difficult tooth preparation, initial marginal leakage. Mercury toxicity: the initiations of toxic effect of mercury was first evaluated in fishermen when they contracted Minamata disease due to the excess mercury in water. Mercury penetrates from the restoration into the tooth structure. The maximum level of occupational exposure considered safe is 50 microgram of mercury per cubic meter of air per day. Amalgam tattoo is a common pitfall of the amalgam restorations. Now come to the bonded amalgam restorations. Recent concepts have suggested that posterior composite resin restoration may replace amalgam as a restorative material. Concern regarding mercury toxicity and greater interest in improved aesthetic has encouraged a move away from amalgam as the material of choice for posterior restoration. However, some of the physical properties of composite resins used in the restoration of posterior teeth, combined with the problem associated with the technique sensitivity during placement, have led some questions with widespread use. Thank you.